these are what I get from disassembling the thumbnail you see. This is actually from my dad's electric scooter, so they're actually lithium-ion batteries. If you don't know anything about the lithium-ion battery, or you do not have a sufficient knowledge, stop doing what I'm doing, because you would easily kill yourself by either short circuit, water damage, puncture, and it will explode in your face. Yeah, it will just explode in your face. So stop doing that. Now, I'm an expert on this. This is what I feed myself for, so I'm lucky enough, I'm happy enough, I can disassemble this. So in this video, I'm going to show you guys how I disassemble the entire pack. So before I disassemble it, I can show you this is actually the pack, and it is pretty simple. You can see this picture, it has the serial number on it. Sorry, I don't have my tools at that moment, and I'm actually the person who, I'm actually the only person who is disassembling it, other than teeny tiny helps. So what I say is I don't have a lot of videos, I only have some pictures. So yeah, if you don't like that, just click off, but I'm sure you would be interested in it if you click in. Now, first you can see these small tiny screws on the top lid. It is actually a pretty simple design for this. You even see the seal sticker. I do believe it has what? QC, yeah, quality control pass on it. Come on, quality control of this. Now, before I even do anything to it, what I'm doing is I'm actually measuring the voltage. The battery can reach a voltage of, I think, 68 volt if it is fully charged, but right now it's very close. It's nominal voltage of 64 volt, slightly higher than 64 volt because of some reason, but yeah, around that. Here is a nameplate. I always like to take a look at the nameplate to see what's the specification. So, so this is actually, it shows the upper limit, which is 67.2, and the lower limit is 48. You will have a continuous working current of less than 20 amps. That's normal. That's actually slightly smaller. They say it's literally 1C because it have a nominal capacity of 20 amp hour. So technically, if you keep constantly discharge the battery, this pack at 20 amps, you will drain it completely from 4 to 0 in an hour. That's how the 20 amp hour comes. Do remember the unit of amps and amp hour is different things. One is like how much water you have in your cup, and the amp just means how fast you can drink it. And I certainly made a mistake there. Yeah, it's a 16 series, so it's the nominal voltage is 60 volts. Pretty decent. There's nothing else on it. I don't want to show you the dimension because you can read it. Okay. So in my previous pictures, you can see these screws on the top. So a simple start would be just unscrew all of these to see what is exactly inside. So I unscrew those, and when I pop it open, yeah, this is all you see. Yeah, it's a little bit raw. It's a little bit how to say? It looks like just small factory stuff. Yeah. Bear in mind that this battery pack for the electric scooter is something like 3 years old, so the technology have evolved a lot. This one is like they just put the cells together and bundle it together like this. So can you say it's cheap? I don't think so. It's probably not that cheap as we sound. But yeah, if it's like that, it's like this, and probably can do the work. Initially, I thought there are actually connectors in here, which means I am able to just disconnect it and do indestructible disassembly, but it turns out I cannot. This is actually, I think they put a wire crimper and crimper it down, and then they heat shrink it, so it's a single piece. I thought about disassemble it from the outside to remove the socket, but obviously, yeah, I find it is impossible, so I cut off the line. Now, when I see this, I think, okay, there are all these white glues, so yeah, adhesives, yeah, come on, let's be professional, right? So I see these adhesives, I think, damn, I need to cut them, yeah, I need to cut them with a knife, and here is what goes dangerous, because if you don't be careful, you will puncture the cells, and good luck. Luckily, these are cylindrical cells, as you can see, so yeah, that's okay. At least they have a steel shell outside, so I'm pretty sure they're safe, but I don't want to scratch them. I want to make it as perfect as possible. And one thing I concern is that there might be glue at the bottom. I actually used a torch to see whether I can see the glue at the bottom. I cannot. Yeah, so I don't know. I tried a little bit to wiggle. Yeah, and it can wiggle. Yeah, honestly, it can wiggle, but I don't know the glue whether it can stick or not. Luckily, after some help, he actually bored it out. So, yeah, thank you very much. Thank you. That works a lot better, because then I do not need to use an angle grinder to grind out the case. The case can be in a complete piece. So you can see this picture shows what the case is. There is indeed a little bit glue, the same white one below, and on the bottom of the battery, the entire assembly, better say, there are more glues. But I do believe what happened is, over time, these glue eventually hardened and going to lose their adhesion. Not very well. You can see some damages from disassembly. I don't know, it might be damage during assembly even. So what these glues are doing is actually they stick the case, the shell, the outer shell, with the battery together. So during driving, you will have a lot of vibration, shaking. I don't think you will have huge shock, but yeah, might be. Then the battery pack will not loose and sloppy inside, because sloppy inside would be very dangerous, not only for the cells, but also for any electronics and cables, right? Yeah, then you can see I poured the entire thing out, thanks to them. And yeah, that one is still connected. I kept it as long as possible to see whether I can, prevent destructive disassembly. But yes, this you see this blue thing, and you may ask me, what is this blue thing? This blue thing is called actually called blue film. Yes, the official term in Chinese is directly translation is exactly blue film. It's actually made of PET, and it do resistance. So it do not say resistance. It do all kinds of protections. Yes, electrical insulation, water intrusion protection. Probably some like thermal stability, and yeah, you can even see the sticker stick on it, which literally means the entire assembly process. Yeah, that's it. So if you want, yeah, that's it. The only way we can go even further is cut it open. Yeah, it is actually wrapped and then heat shrink it. Yeah, heat shrink it. So it's actually wrapped and then heat shrinked. So yeah, So the only way is we cut through. So again, I go to my trusty knife. Yes, this is even more dangerous, and I choose a part which I feel is empty because I don't want to puncture the cells. You know, I can easily kill myself at this moment, but I don't want to do that. So you can see I cut it and then completely off wrap it. To my amazing, there's actually some these kind of stickers, the sticking foam kind of cardboard in it. I do believe the biggest purpose for it is actually provide insulation, so also protection for these electrical connections. You can see about all these electrical connections there. If you connect this series with this series, then it's no good, because what you are going to do is it is likely you are going to short circuit the battery, get some sparks. It's good if you want to frighten yourself, but don't do that. It's bad for the battery and bad for everything. Okay, one thing I want to see the eagerest is actually this board. This is actually a BMS board. So what it do is it monitor each single string, or say each single series. So each single series have a nominal voltage of 3.6 volt, and it will change depends on your state of charge. Then it monitor it to prevent overcharge, over discharge. If anything abnormal happen, it will cut. But I will make another dedicated video for this part, because I want to learn a little bit more about it. Then you can see the cells, it have two layers. I tear out the top surface, and this is what I see. So this is actually the negative side. So you see these four cells at the very bottom is one series. So it's actually four parallel cells connected together. We call it 4P. And the four cells at the bottom is series with those four cells, and 4 by 4 by 4. So it's a 4P configuration, and as I said, it's a 6S configuration. So when you consider about that 4P6S, oh no, not 4P16S, it would be 64 cells. Is it 64 cells? Probably. My math is terrible, so don't count on me. Count by yourself. That's it. That's what this looks like. But it's a double layer, so I go further to rip it open. So initially they are sandwiched together, one layer on the top of the other. And what I'm doing is actually I'm split it apart. The only thing I can use is actually a flathead screwdriver, and this is actually what frightened me most, because if I puncture the green sticker, cardboard paper, anything, any term in it, then what I'm going to do is I'm going to directly contact with you know, those yes, those current collectors, or even directly stab into a cell. If I get lucky enough, then bye-bye, you would not see this video. So what I find interesting is I succeed. No. What I find interesting is actually they have a piece of foam in between to provide it some cushion. That's great, because I do believe when they assemble it, they need to put it down into the case, and they certainly want to have some swelling in it. Yes, and this is the picture I like most. So you can see all the groups. Starting from the left, this is series number 1, so most negative side. Then number 2, number 3, number 4, number 5, number 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, so that's the entire configuration. And hey, you may say, how is the connection between 2 and 3? The 2 and 3's connection is on the other side. I just didn't bother to show it because it's even boringer than this side. That side is just 1, 2, 3, 4, 5, 6, 7. Yeah, 7, 8. Then that's it. Damn, I should know that because it's 16 divided by 2 minus 1. Anyhow, yeah, so yeah, that's it. That's what I want to talk about, and goodbye. No, I actually have a little bit more to say. This is what actually interested me most. Initially, I thought all these cells are probably 16. Obviously, my brain is not working, and they are 18650s, or as Elon Musk speaking, 1865. So I thought they are those small cells, but which is used in the laptop. They are not. What they are actually very big cells. They have a diameter of 32 millimeters and a height of 70 millimeters. So if you speak, they are cells which is 3270. And what they are good is exactly they are actually cells which is the same height as those in the Tesla battery pack. The only thing is they're way bigger than the cells in the Tesla battery pack, because the Tesla battery pack is 2170, this is 3270, so it's 11 millimeters larger in the diameter, which makes them which makes them actually look really like dynamite if you treat them uncarefully. So treat them with care. Wow, what I did is I actually take one series of it. I do not need all 64 cells, it's too much for me. And I took one series off, measures its voltage, and its voltage is actually at 4 volts. So they are still a little bit on the high state of charge side. I would say they have a SOC of probably around 75%. So what I'm going to do is I'm going to fully discharge it, then show you more detail about the current collectors, show you more detail about a little bit design of them, and eventually tear it down all the way into the cell inside to see whether they have the tabless design, which Elon said is new for them. I do believe it's early this year in the battery day. So if you like renewable energy, yes, this is actually exactly what I'm working at. So these are something very interesting. I wish you can enjoy this, and yeah, stay tuned for the next video. So because I'm going to tear it down all the way to the center.